Session 02 Production Reliability. Celery's performance and stability in production depend on choosing the right concurrency model and tuning your configuration for resilience. Today we cover the 4 concurrency pools, the reliability settings that keep tasks alive when workers crash, and how to choose the right queue type for critical data. Celery supports 4 concurrency models. Pre-fork is the default. It spawns independent child processes, bypasses the GIL, and uses every CPU core. Ideal for image processing and video transcoding. Jevent and Eventlet use asynchronous greenlets. One worker can handle thousands of concurrent connections with very little RAM. Perfect for API calls and web crawling. But beware, a CPU-heavy task under Jevent blocks the entire worker. Solo runs one task at a time, useful for single-threaded GPU work. Here is how you pick the pool. For CPU-bound work like image processing, use pre-fork with one worker per core. For I/O bound work like thousands of HTTP calls, use Jevent with high concurrency. But never put a CPU-heavy task under Jevent. It blocks the single OS thread and stalls every other task in that worker. In a high-risk production environment like AWS ECS, override the Celery defaults with these 6 reliability settings. The critical one is task_x_late equals true, paired with task_reject_on_worker_lost. This means a message is acknowledged only after successful execution, and a crashed worker's task is rejected and returned to the queue. Set worker_prefetch_multiplier to 1 for even load distribution. Higher values let a worker hoard tasks while others sit idle. Here is what happens when a worker crashes. Worker A picks up the task and starts running. Then the worker crashes out of memory or a SIGIL signal. Because X_late and reject_on_worker_lost are both enabled, the broker returns the task to the queue. Worker B pulls it and re-executes. The task survives. But this requires every task to be idempotent. Running it twice must not corrupt your data. Time limits are mandatory so no task can hang forever. Here you see a worker receiving a report generation task. After 25 seconds, soft time limit exceeded fires inside the task. This gives you a chance to flush partial work and mark the report as failed. But the task is still running, so 5 seconds later the hard time_limit triggers a SIGIL. The worker is lost, and the task is requeued for another worker to try. Always set time_limit a few seconds above soft_time_limit so your cleanup handler has time to finish. For broker-level data resilience, RabbitMQ operators recommend moving from classic queues to quorum queues. Classic queues store data on a single node. If that node fails, your tasks are gone. Quorum queues replicate data across multiple nodes using raft consensus. A write is committed only after a majority of nodes acknowledge it. This is the standard for financial transactions and core business tasks. The trade-off is higher RAM usage across the cluster. Because task_x_late means a crashed worker's task gets redelivered and re-executed, every task must be safe to run more than once. Use conditional updates like update with a status check instead of blind insert. Make external side effects like sending an email check an idempotency key before firing. And never increment a counter without a guard that prevents double counting. If a task is not idempotent, do not use X_late. Session 02 Recap. We learned to pick the right concurrency pool. CPU work goes to pre-fork, I/O work to Jevent. Enable X_late and reject_on_worker_lost so a worker crash does not lose your task. Set prefetch_multiplier to 1 for even load balance. Use quorum queues for critical data that must survive a node failure. And always make your tasks idempotent when using late acknowledgement. Next session we cover Celery Canvas workflow orchestration with chains, groups, and chords.